Hi there, so today's lesson is 7.5 sectors of circles. The objectives today to work out areas of semicircles and quarter circles, to work out the area and arc length of sectors, and to solve problems involving sectors of circles. Before we start our prior knowledge check, we need to know what is meant by perimeter, so that being the distance around the outside of a shape. You should also be able to find the area and circumference of a circle. We did that in the previous lesson, so if you're not sure, please go back to the previous lesson first. You should be able to find a half or a quarter of a number. So remember, a half dividing by 2, a quarter dividing by 4. And you should know there are 360 degrees in a circle. Things you'll need to complete this lesson: you need your maths book or some paper to write on, a pen or a pencil to write and draw with, a ruler and pair of compasses for drawing diagrams, and a scientific calculator which needs to have the pi button and a square button on it. So just make sure you've got those before you start. Okay, parts of a circle. Then last lesson we used radius, diameter and circumference. So radius from the center to the circumference, diameter from one side to the other going through the center, and circumference the distance around the outside. Okay, but there are other parts of the circle we need to know the names of. Now, we did briefly look at these last time. So we have a chord, which is any line across from one side to the other, but not the diameter, because it has its own special name, so not going through the center. We have an arc, which is part of the circle, and it could be any part nearly all the way around as long as it doesn't meet. We have a tangent, which is a line outside the circle just touching at one point. We have a segment of a circle, so a chord divides the circle into two segments. We have a sector, so if we take an arc and two radii, then that splits it into two sectors. And today, that's the one we're going to look at. So we're going to use the arc and we're going to use the sector, as well as using our radius, diameter and circumference that we've previously used. Okay, so we're going to start with the area of a semicircle then. So a semicircle is half a circle. So to find the area of a semicircle, we find the area of a full circle and we half it. So here's an example here. This is a semicircle. We've been told it has a radius of 4 centimeters. That's from the center to the outside edge of the circle. So for any circle then, remember the formula for area of a circle is pi r squared, pi times the radius squared. So if we want a semicircle, it's pi r squared divided by 2, or half pi r squared, whichever you prefer. So for this particular semicircle then, we would do pi times 4 squared, because the radius is 4, and divide that answer by 2. We can put that into our calculator in one go, or you can do the top line and then divide that answer by 2 separately if you want to. If we work out just the top line, 4 squared is 16, we get 16 pi. If we do 16 divided by 2, we get 8 pi centimeters squared. Now, sometimes you're asked to give your answer in terms of pi, and that's what it means by in terms of pi. It means a number multiplied by pi. If we put that into our calculator though and work that out as a decimal, we get 25.1327, etc. So remember, we write down at least 4 decimal places before we do any rounding, and we're going to round that then to 1 decimal place. We get 25.1 centimeters squared. Don't forget your units. We are talking area, so either millimeters squared, centimeters squared, meters squared, or kilometers squared, depending on the information we've been given in the question. Okay, so what about a quarter of a circle then? So a quarter of a circle, we would find the area of a full circle and divide it by 4. So again, another example. So we've been given a quarter of a circle and we've been told the radius is 3 centimeters. So remember, the area of a circle pi r squared, so a semicircle is pi r squared divided by 4, or a quarter times pi r squared, whichever you prefer. So again, we're going to substitute our radius of 3 into our formula. So we get pi times 3 squared divided by 4. Now again, If you want to do this, you can type this straight into your calculator. I'm going to work out each stage as we go. So 3 squared is 9, so we get 9 pi divided by 4. Now if we want that in terms of pi, we can say that's 9/4 pi, or if we do 9 divided by 4 in our calculator, we get 2.25. So we could say it's 2.25 pi centimeters squared. So remember, in terms of pi, it means I've still got the pi symbol in my answer. I've not calculated the whole thing. If we put that into the calculator to get a decimal, we would get 7.0685, etc. And again, if I want to round to one decimal place, 7.1 centimeters squared. Make sure you're happy with those 2 examples before you move on. If you need to, pause, rewind and watch those again. Okay, so now it's your turn then. So for each of the 4 shapes, you need to find the area. You need to give your answer in terms of pi and then give your answer to 3 significant figures. Pause the video, have a go now. All right, let's have a look at the solutions then. So first one, we've got pi times the radius of 4.8 squared divided by 2, because it's a semicircle, it's half of the circle. So in terms of pi, we get 11.52 pi. And if we then press our SD button on our calculator to get our decimal, we get 36.1911 to 4 decimal places. And to 3 significant figures, remember 3 significant figures means the first 3 digits. So 1, 2, 3 digits. We round using our 4th digit, so the 9 makes the 1 into a 2, and we get 36.2 centimeters squared. So remember, we're round to 3 significant figures, not decimal places this time, so it may change for each question. Okay, our second question over here then. Now we know the formula is pi r squared, and we've been given diameter here, so we need half of that. So we're going to do pi times 6.2. Sorry, that should say squared. Okay, there we are. Sorry about that. So pi times 6.2, so half of 12.4 is 6.2 squared, divided by 2. So again, in terms of pi, 19.22 pi, and for our decimal, 60.3814, etc. To 3 significant figures, again 1, 2, 3, the 8 makes the 3 into a 4, so we get 60.4 centimeters squared. Now I'm going to move on to this one then. This one is a quarter of a circle. I can see it's a quarter, it's got a 90-degree angle in here, making it a quarter of a circle. So we're going to do pi times 3.2 squared divided by 4 this time, so we want only a quarter of the circle. So again, in terms of pi, you should have 2.56 pi as a decimal, 8.0424, and to 3 significant figures. So this time 1, 2, 3 is the 4, the 2 means the 4 stays a 4, so we get 8.04 centimeters squared. Okay then, our last one of these, and we've got another quarter of a circle. So again, we can see the 90 degrees here. So we're going to do pi times 19 squared divided by 4 this time. And if we put that into our calculator, in terms of pi, we get 90.25 pi. And as a decimal, 283.5287, which equals to 3 significant figures. So 1, 2, 3 this time. The 5 changes the 3 to a 4. We get 284 millimeters squared. Make sure you've checked your answers before you move on. Okay then, so here we've got the area of a sector then. So a sector is a slice of the circle, like a slice of pie. So we don't need to limit ourselves to just semicircles and quarter circles. We can find the area of any sector of a circle as long as we know the radius and the size of the angle of the sector that we're interested in. So for any circle with a radius of r and a centre angle, which we're going to call x, our formula would be x divided by 360. Now that's our fraction of the circle. So remember, an entire circle has 360 degrees, and we want x out of that 360. times pi r squared, which is the area of the circle. So we're finding out what fraction of, remember of in maths is times, the circle area we want. So we've got the fraction of the area of a circle. Let's have a look at how that works then. So for these two then, we want to find the areas of these sectors. So our first one, we've got 72 degrees and we've got a radius of 6. So our formula, remember, is our angle over 360, the fraction of the circle of the area of the circle. So x is going to be our 72 and r is our 6. So we substitute those into the formula first. Now we can type that into our calculator. If you know where your fraction button is, you might want to use that to do your 72 over 360. If not, remember 72 divided by 360 is the same. Then times pi times 6 squared, don't forget your squared. And as a decimal to 4 decimal places, we get 22.6194. And if we round that to 3 significant figures, 22.6 centimetres squared. Again, remembering our units. Now this one at the bottom, we want the area of the yellow part, but they've told us the angle for the white bit. So our first step here is to actually find out the angle for the sector that we want. So we're going to have to do 360 minus the 34 first to get our angle to put in place of x. And that comes to 326. So sometimes they give you the bit you don't want. Take it from 360 to find the bit you do. Our radius, we're still told here, is 3.2. So we've got 326 degrees out of 360 times pi times 3.2 squared. So pi times the radius squared. Pop that in our calculator. We get 29.1316, etc. And again, rounding to 3 significant figures, 29.1 centimetres squared. Make sure you've copied down those examples before you move on to have a go yourselves. Okay, so now it's your turn. So pause the video, have a go at finding the area of the shaded sectors. So make sure you're careful about which angle you've been given and which angle you require. Okay, let's have a look at the solutions for these then. So our first one, our angle x is 25 and our radius is 43. So we've got 25 out of 360 times pi times 43 squared as a decimal, 403.3892, etc. to 3 significant figures, 403 millimetres squared. So again, check your units. Our second one then, now again they've given me this angle here which is 39, but I want the yellow one, so I need to do 360 minus the 39 first. So that comes to 321 out of 360 times pi times our radius, which is 4.1 squared. We put that in our calculator, we get 47.08090, etc. And to 3 significant figures, 47.1 kilometres squared. Finally, our last one then. So again, we want the blue shaded bit, but they've told us the angle on the outside here. So we have to do 360, take away the 285 there, and that leaves us with 75 out of 360 times pi times our radius of 5.8 squared is 22.01732, etc. And to 3 significant figures, 22.0 metres squared. Make sure you check those before you move on. All right, so now we're going to have a look at some problem solving then. So below is the Pac-Man logo. The open mouth has a radius of 3 centimetres and is open at an angle of 48 degrees. Find the area of the yellow logo. Okay, so with these you can either pause the video now, have a go yourself, see if you can do it on your own, or you can work through it with me. Okay, so our first step then is to recognise that we're told the radius is 3, so that's from the centre to the edge of the mouth is 3, but that the open mouth is 48, so that's this bit in here, that's the white bit, Now again, we want the yellow bit. So our first step is to do our 360 minus 48, which is 312 degrees. Once we know that, now we can go ahead and work out the area of Pac-Man. So remember, it's the fraction of a full circle, so 312 out of 360, times the area of a circle, pi, times the radius, which was 3 squared, and that comes to 24.5044, etc., to one decimal place, 24.5 centimetres squared. Okay, we're going to move on now then to look at arc length and perimeter of a sector. So an arc is a section of the circumference. So here in orange we've got an arc. Now remember, an arc can be small like this, or it can be really large. It can go all the way around till nearly back at the beginning. So as long as it doesn't join back up to the beginning, because then it would become the circumference, we call it an arc. We've also got two radii here and our angle x in the middle, making our sectors. So we can find the arc length and perimeter of a sector if we know the radius or the diameter and the angle. So our arc length, then the formula for our arc length is, again, x out of 360. So it's the fraction of the circle we want, but this time we're multiplying that by the circumference of the circle, because we want to know what fraction of the circumference we require. So pi d, remember, is the circumference of the circle, and the diameter d is 2 lots of the radius. Make sure you write that down before you move on. So to find the perimeter of a sector, remember perimeter means the distance around the outside, I not only need to find the arc length, but I need to then add on the two radiuses as well. So we're going to practice finding the arc length and finding the perimeter as well. So let's have a go with this example then. So for this sector, we're going to find the length of the arc, and then we're going to find the perimeter. We're going to give our answer to an appropriate degree of accuracy. So for this first bit then, we need to find the length of the arc. So we're going to use our formula. Remember, we want to know what fraction of the circumference we need, and our circumference formula requires the diameter. So our radius was 12. 2 times 12 is 24, so our diameter is 24. We can now put that into our formula. So remember, x out of 360 times pi times the diameter times the circumference of the circle. So our angle this time is 50. So 50 out of 360 times pi times the diameter of 24 will give us the arc length. So 10.4719 to 4 decimal places, or 10.5 centimetres to 3 significant figures. Now remember, we're using centimetres this time because we're talking about a single length. The perimeter of the sector then is not just the arc around the outside, but it means we walk all the way around. So we've already got the arc, which is 10.5, and then we come down here, which is 12, and we need to go back out again to the beginning, which is another 12. So the perimeter is the arc length plus the radius again. So 10.5 plus 12 plus 12, which is 24.5 centimetres to 3 significant figures. Make sure you copy down the example before you move on to have a go at your own ones. Okay, so again, it's your turn then. So for the first two, you're just asked to find the arc length, and for the last one, you're asked to find the perimeter. Give your answers to an appropriate degree of accuracy for each answer. Pause the video, have a go now. All right, so let's have a look at the solutions for those then. So for the first one, we've got our angle of 130, so x is 130. Our radius is 4.9. Now remember, we need the diameter, so we need to double that 4.9 there. So double that will be 9.8. So our arc length is 130 out of 360 times pi times our diameter of 9.8. which comes to 11.1177, etc., or 11.1 centimetres to 3 significant figures. Now it says give your answer to an appropriate degree of accuracy, so you may have rounded slightly differently to me. That's why we write down at least 4 decimal places before we do any rounding, to make sure we do know what the majority of the number is before we choose what we want to round to. The second one then, again, we've been given the radius, so we're going to need to find the diameter first, so 2 lots of 18. We've also been given the angle that is not the sector we want, so we're going to have to do 360 minus 40 as well. So that's going to give us 320 degrees, and it's going to give us a radius of 36. So, sorry, diameter of 36. So our diameter is 36. X was, sorry, not 40. Sorry about that. You see, even the teachers make mistakes there. So we did 360 minus 40, because we don't want the 40 there, which is 320 out of 360 times pi times our diameter of 36, which is 100.5309 and 101 millimeters to 3 significant figures. Our final one, then we're asked to work out the perimeter. So again, we're going to start with the arc. So we've got our 80 degrees, which is the right angle that the correct angle that we need now. And we've got our radius of 9.5, so we need to double that again to get our diameter. So our diameter is going to be 19. Our arc then is 80 out of 360 times pi times 19, which gives us 13.2645, etc., or 13.3 centimeters to 3 significant figures. But we were asked for the perimeter, so we need to add on the radius and the radius again to get back to the beginning. So we've got 13.3 plus 9.5 plus 9.5 is 32.3 centimeters to 3 significant figures. Okay, check yours and make sure you've done yours accurately. Okay, finally then, our problem solving with sectors. So we've got the aerial view of a Dalek's laser arm, and it can move through a 40-degree angle. So if the arm is 50 centimeters long, what is the length of the arc made? And the range of the laser beam is 25 times the length of the arm itself. What is the length of the arc made by the laser? So again, you need to choose. You can pause the video, have a go yourself now, or you can wait and work through it with me. Okay, so we know our angle is 40 degrees then, so that's this angle inside here, and we know the radius of the arm is 50 centimeters long. So we can use that to find our arc. So remember, we need the diameter, which is 100 centimeters, and our formula is our angle out of 360 times the circumference of the circle, which is pi times the diameter. So our angle x is 40, so 40 out of 360 times pi times our diameter of 100 is 34.9065, and again round appropriately, 34.9 again to 3 significant figures. Our second part then, the range of the laser beam is 25 times the length of the arm itself. What is the length of the arc made by that? So remember, our arm is 50, so we need 25 times 50 is 1,250. But the laser is coming out from the end of the arm, so to get us to the center of that arc, then we are going to need to add on the other 50 centimeters. So the laser plus the arm is 1,300 centimeters. Again, our formula requires diameter, so we're going to need to double that to get the diameter. So our diameter is 2,600 centimeters. And we're going to put that into our arc length formula. Our angle is still 40, so 40 out of 360 times pi times our new diameter of 2,600 comes to 907.5712, which is 908 centimeters to 3 significant figures. Or you might choose to give that as 9 meters if you wanted to convert it to meters and round it appropriately for meters. So approximately 9 meters. Okay, thank you for working through this lesson today then. Next lesson, we're going to be moving on to look at cylinders and spheres.